Hello students, it's Blogan here again. In today's lesson I'll tell you why you need to store data in memory, what data you'll store in memory, show you a complete table of standard data types, talk about each memory type from the table, and introduce you a little to the user data types that you'll also use, but later. Let's start. Okay, we know how to display text on the screen, but this is damned not enough. The next goal is to create data, manipulate it, and also display it on the screen. But why do you need to save data at all in programming? Let me explain. Imagine that you're writing a program that asks the user to enter two numbers and prints their sum. The user can't enter two numbers at the same time. First, you need to enter the first, then the second. So, after entering the first number and until the second number is entered, the first number must be stored somewhere in memory. When the user enters the second number, then the program will go to the memory area where both the first and second numbers are located, add their values, and write the sum to the third memory area. And at the end, the program reads the value from this area in order to display it on the screen. And this is how it works with all data. All data that the program works with must be stored in memory. You must write a special command that will tell the program to allocate space in memory for a specific value. What memory am I talking about? Your computer has random access memory, RAM. It usually takes up 4, 8, 16 or 32 or more gigabytes. This RAM contains all the data needed by programs that are already running on the computer. That is, when you run the program, it contacts the operating system and asks it to allocate its area in RAM for its data. When you close the program, the entire area is deallocated for other programs. If you know what the task manager is in Windows, then you've seen a list of open programs in it. There you can see how much space in RAM is allocated for each program. But this is not the topic of my course, so let's return to the data. Let's figure out what can be stored in memory, specifically in the C++ language. Only ones and zeros are always stored in memory, but writing these numbers there is very inconvenient. Therefore, we need something that we can relate to in real life. For example, numbers. The number of oranges, your monthly salary, the number of soldiers in a platoon, and so on. All this can be represented using numbers. But there are different numbers, positive, negative, zero, and fractions or decimals, and all of them must be stored in memory in order to use them. We also sometimes work with text. To do this, we need a data type that would describe a specific character, and it also exists in C++. That is, we can store in memory not only numbers, but also characters. There is one last type that might not be clear to you. This is the logical type. Very often in life, we come across situations that ask us questions, the answer to which can be given as yes or no. For example, is it raining outside? Yes. Do you have a car? No. Do you want to buy a new couch? Yes. And so on. So the answers yes or no can be also stored in memory for later analysis. For example, you can parse the expression, does the user want to start a game? If the answer is yes, then the code that starts it is run. If no, then the program does something else. So, what do we have? In C++, you can store numeric, symbolic, and logical values in memory. All these values have their own type, that is, the data type. Accordingly, in this lesson, I'm going to tell you about standard data types. In the future, when you create your own data, you'll need to specify its type. For example, you'll write code that says, allocate me a memory that has this name, this value, and this data type. We'll learn how to do this in one of the following lessons, but to do this, you need to learn these types of data. Let's get to them. Here is a table of standard data types found in the C++ language. You'll be surprised, but in C++ there is simply no type called integer. There are many more of them. The situation is similar with decimals. I'll answer why later. Let's take a look at the table first. It's divided into 4 sections: integers, decimals, characters, logical. In each section, you see the name of the data type, the number of bytes it occupies in memory, the range of values it can hold, and examples of values for the data type. The first and most popular types are integers. There are 4 of them: short, int, long, and long. They differ in two things: the amount of memory they require and the range of values they can hold. For example, the short type in my operating system takes up 2 bytes. Int and long take 4, and long takes 8. The more memory a type needs, the larger the range of values it can accommodate. That is, if you want to store the number, for example 55, in your program, then you can choose any type for this, since this number is included in any of these ranges. But if you choose the number, for example 100,000, then it will no longer fit into the short type. It requires a larger type. The question may arise: why then choose the type short, int, or long if long seems to be the coolest of them and can hold the most numbers? It's a matter of memory. There are situations when memory is important and its allocation needs to be limited. You may also ask, why are there so many types to describe an integer value? The fact is that, again, there are situations when you need to write a program for a system that has a small amount of memory, and you need to create some data that will store small numbers such as 3, 8, and 5. If you select the long type for all 3 values, then your program will request 24 bytes from the system, and this number may be critical. The system may not give it. Therefore, in such situations, you need to save memory and choose, for example, type short. 3 short values occupy only 6 bytes. Also, you may have a question: why are int and long identical? The fact is that on my system they are identical. On other systems they may take up a different amount of memory, and not only them. A short type can take up 1 byte, an int type can take up 2 bytes, long can take up 4 bytes, and so on. It's not always the same, but in modern 64-bit systems these types take up exactly that amount of memory. What type of memory will we choose to work with integers? It will be type int. Firstly, our computer systems have a huge amount of memory, so there is no point in choosing a smaller short type. Secondly, if you need to store a number that doesn't fit into the int range, then only choose the long type. Thirdly, the int type is the most efficient. This means that the computer processes values of type int the fastest. Therefore, our preference for integer numbers is the int type. Let's quickly look at the names of these types. Main int. This is short for integer. Name short is a synonym for short integer because the range is smaller. Name long is a synonym for up to long integer because the range is larger. Well, at least sometimes it's bigger. I think you can guess now why the first type is called that, long. Let's move on to the next section. There are fewer types here, but not very much. We can't store fractional values in integer types. For this, we need floating point data types. There are 3 of them: float, double, and long double. As you can see, the difference between them is also in the number of bytes and range of values. Accordingly, if you have little memory available, choose a smaller type. If you need a larger value, choose the bigger. Also, these data types can store integer values. Why then do we need integer data types at all? The point is that they are more efficient than floating point data types. The computer processes them faster, that's all. So if you want some data to store integer values, choose integer types, not floating point types. Let's return to ARM types. They can store not only the whole part, but also the fractional part. And here there's a small thing to know. The more memory a type requires, the more precise its value will be. What does number precision mean? Precision determines how many digits there are after the period. The more digits in the number, the more accurate the number. So the type float has less precision than the type double. Also, the double type is processed more efficiently by the computer than others, so for real numbers we'll choose the double type. If memory is important and accuracy allows, choose float. In other cases, double is your choice. All that remains is to figure out the type names. They describe the precision of a number. Float is like a floating point number. The period floats in a number because if you write a sequence of digits, you can put a period anywhere to turn the sequence into a real number. And it turns out that since it can be placed anywhere, it seems to float. This is where the name floating point numbers comes from, abbreviated as float. The word double describes the double precision of a number compared to normal precision of a float type. Hence the name. Well, long double on some systems takes up more memory, and the name should also be clear to you. Let's move on to the next section of the lesson. Everything in this section might be tougher than in the others. Before describing these types, I need to explain to you what ASCII and Unicode are. The fact is that each character in memory is exactly stored as a number. Therefore, each character has its own number or index. And there are a large number of tables with the numbering of these characters. The most popular ones are ASCII or ASCII and Unicode. Let's Google ASCII table and look at it. You should know that now the console with which we are working and outputting text to it works with ASCII by default. Because of this, you can only output those characters that are listed in this table. Here you see special characters that we're not interested in, dollar symbol, exclamation mark and others, number symbols and symbols of English capital and small letters. Let me now try to display a line that has characters that are not included in this table, for example text in Ukrainian. When you run the program, you might see this. These are invalid characters. The console doesn't know how to output them and output them like this. Let's go back to the table. Here we can find a small letter A. Its number is 97. This letter is written in memory as 97, and so with the other characters. ASCII is a very old character encoding standard, and it's still used by default in C++ console terminals. Please note that in the table, the maximum number is 127. This standard supports 128 characters. Don't forget the character number at 0. 1 byte is enough to represent every character from this table, but 256 characters can fit in 1 byte. Where is the other half then? You can also find it in the internet, but it doesn't work exactly the same on different systems. I recommend reading about the standard at least on Wikipedia. You'll learn a lot of new things. Just Google ASCII and you find it. There's another encoding table that is now considered the most popular, Unicode. It currently stores about 150,000 characters. This is a huge amount, which contains letters from almost all languages of the world and a huge number of other symbols. Why then is the console not configured for this encoding by default? And all because of backward compatibility with old programs. However, there is nothing stopping you from writing code that will change the console encoding. I won't show it because there are enough characters from the ASCII table for the entire course. If after the course you have a desire to change the encoding, then you can find the answer in 5 minutes on the internet, believe me. Why did I tell you this? The point is that character types are directly related to these encodings. Let's start from the first type, char. The word char is short for the word character, so it's char, not car, believe me. The char type is the most efficient type, but it takes up at least amount of space, only 1 byte. It's fully ASCII ready due to its range of values, so I'll be using it throughout the course. The WCHAR-T type stands for wide character type. It occupies at least 2 bytes, which is why its range of values is much larger. It usually stores Unicode characters, but since this type has different amounts of memory on different platforms, several more types were added along with it: char8t, char16t, and char32t. They all have numbers in their names which describe the number of bits they store. Since 1 byte has 8 bits, they occupy 1, 2, and 4 bytes respectively. There are different representations of the Unicode encoding called UTF-8, UTF-16, and UTF-32. If you need to store characters in data types that have a specific number of bytes, then choose these. In other cases, if you're writing a program that will support different languages, choose WCHAR-T. If you are writing programs in which only English will be used, choose char. I'll use it throughout the course. Well, that leaves the last section, in which there is only one type. I explained to you that you need to store the answer yes and no somewhere. This is in fact only 2 values. They don't need many types, just one is enough. And this type is bool. It takes up 1 byte and can store only 2 values: the number 1, which is interpreted as true, that is yes, and 0, which is interpreted as false, that is no. You may have 2 questions. Why does the type have such a name, and why does it need as much as 1 byte if one bit is enough for two values? The answer is, this type is named after the mathematician George Boole. Secondly, the minimum unit in memory that has its own address is 1 byte, no less. Therefore, in C++, there are no types that will occupy less than 1 byte. Let's move on. You can append the words unsigned and signed to integer and character types. What do they give? Let's look at integer types first. If you look at their ranges, you will see that they all have an equal amount of negative and positive values. But if you add the word unsigned in front of them, then this range changes. Now, these types can't have negative values, but there are now twice as many positive ones. There are situations in which you don't need negative values when creating data, and at the same time you need a value that, for example, doesn't fit into the type short, but you don't want to choose the int type since it can take up more memory. You may encounter a combination of the word unsigned and some type of data in problems that describe entities that cannot be negative in principle. For example, the quantity of something, it can't be negative, or the size of something. You're not forced to use the word unsigned, but you should know what it does to an integer type. In general, the word unsigned means without sign. Sign in this case is the minus sign symbol. Numbers can be with or without a minus. Accordingly, these are unsigned and signed numbers. I think you can already guess what the word signed does. You can add it to an integer type, but this makes no sense since all integer types are signed numbers by default. This word is mainly used with character types. Since the characters are actually stored in memory as integer values, you can add the words unsigned and signed to them as well. The point is that the value range of character types can change. For example, in some systems, the char type has a range from -127 to 126, and in others from 0 to 255. There are situations when a programmer needs to create a type that will definitely have either one range or another. In most cases, as programmers, you won't need to use these words, but it's still useful to know why they might be needed. For example, unsigned char is exactly the range from 0 to 255, and signed char is exactly the range from -127 to 126. That's all. Also, I want to add a bit more information. These words cannot be used with float, double, long double, and bool types. Okay, let's end the lesson by telling you something else. I showed you the standard data types. Standard. This means that they are basic, fundamental to the C++ language. But from them, you can create other data types, such as enumerations, structures, classes, bit fields, and they are already called user-defined data types, or just user data types, because you, as a user of the C++ language, create them yourself. In reality, there are just combinations of standard data types. We'll study each of them in detail in separate lessons. In 2 lessons, we'll finally start creating data in code, assigning values to it, doing various operations on it, and displaying it on the screen. To do this, we need knowledge of the data types that I showed you in this lesson and the knowledge you'll gain in the next lesson. Because all that's left is values by themselves. I mean by it a thing named literals. I'll explain what it is in the next lesson. We'll even use different literals by outputting them on the screen. And that's the end of this lesson. Thank you for watching. If you like this video, you can support me by liking this video, writing a comment under it, subscribing to the channel, donating using the link in the video description, or becoming a sponsor of my channel. All these things popularize my channel and motivate me to continue recording lessons for you. Goodbye.